Find any vertical asymptotes and describe the function's behavior near the asymptotes. Okay, well this is the first one we've closely looked at asymptotes with, so let's take a good detailed look at what goes on here. I'm making a table of values, and we're just going to throw some numbers at this function to see what its general behavior is. If x is negative 4, then our y is 3 over negative 4 minus 2, which is 3 over negative 6, which is minus 1 half. So over at minus 4, where if that's minus 1, minus a half is right about there. If x goes to minus 3, we get 3 over negative 5, which is negative 0.6. So a little more negative, but you can barely tell the difference. Negative 2, we get 3 over negative 4, which is negative 0.75. Again, not much change. If it's negative 1, we get 3 over negative 3, which is negative 1. So this is picking up a little bit of a curve, but it's very, very subtle. No big deal yet. If x is 0, we get 3 over negative 2, which is negative 1.5. So if that's 2, that curve's definitely getting more pronounced now. At plus 1, we get 3 over negative 1 is, I got negative 1.5 here, I forgot to write it in. 3 over negative 1, we get negative 3. 1, 2, 3. And at 2, we get 3 divided by 0, which is undefined. So we can't actually put in x equals 2. The function basically produces an error. Or we say it blows up, it becomes arbitrarily large, it becomes undefined. Something bad happens at x equals 2. What if we just power through that and keep going? What if we put in something like 3? We get 3 over 3 minus 2, which is 3 over 1, which is 3. That's all right. 2, 3. If x is 4, we get 3 over 2, which is 1.5. Okay, well, it looks like the panic is over. This thing is producing sensible numbers again. And if x is 5, we get 3 over 5 minus 2. That's 3 over 3, which is 1. It seems to be dropping back to normal and giving positive results now. So if you sketch more points, you find that the curve does this and curves down and curves down. It starts to curve very sharply here. And it turns out it just drops as you get very close to 2. For example, if I put in 1.99, very close to 2 but not quite, what happens to this function? We get 3 over 1.99 minus 2, which is 3 over negative 0.01, which is minus 300. So when we're over here, the y value is minus 300. It's way down there. And if you go to 1.9999 or something like that, you get even bigger negative numbers. So this thing just falls off a cliff as you get extremely close to 2. It does that. On the other side, if you do a value like 2.001, just barely to the right of the asymptote, this comes out to 3 over 2.001 minus 2, which is 3 over 0.001, which is 3,000. So over on the other side, just to the right of the asymptote, we get extremely high y values, and then the function drops, like so. This kind of behavior is called asymptotic behavior. It's how most functions behave around an asymptote. Asymptotic behavior. The line curves almost like it's trying to avoid running into this line. It goes an infinite distance down, or here an infinite distance up, without ever making contact with this line because it's not allowed to. Please note, it is possible to have a function that actually runs into a line like this. You can have a curve that does that, and then it's just undefined for a second and then carries on. That is not asymptotic. to be asymptotic, you have to travel for an infinite distance, like these two lines are doing. This goes down forever. This will get to minus 300 and minus 3,000 and minus 300 million if you get close enough to the asymptote, and the same on this side. So around this asymptote, there's a lot of different language they use here. You can say that this line, I'll write out some of the common phrases that mathematicians go out. People will say it goes to minus infinity. We can say that it becomes unbounded. Unbounded means there's no limit to how low it can get. You can say it becomes large and negative. Or infinitely large, or sometimes they say arbitrarily large, which means pick any number you want, it'll get that big. Any of those things are true for this side. And on this side, the same thing. We can say it goes to plus infinity as you get closer to the asymptote. Or again, it becomes unbounded, or it becomes large and positive. They also, there's the unscientific but popular phrase that the function blows up at x equals 2. This is fine, and everyone will understand you if you say this. The weakness of this one is it doesn't explain whether the function blows up towards positive infinity or whether it blows up towards negative infinity. Blows down is silly, and no one ever says it, even though it would kind of make sense that the function is going down into the negative numbers infinitely far, so you won't hear that one. But when speaking casually, mathematicians will look at this function and say, oh, that's going to blow up when x gets to 2. So curvature like that is what we expect to see when there's a division by 0 in a function, and that is asymptotic behavior.